Hi everybody, welcome back. Another Kubernetes Lumbye example. In this example, we're going to talk a little bit about deployment and ReplicaSet, which allows developer define your application desired state as well as how many applications will be running on Kubernetes cluster. Let's get started. So first of all, let's take a look at what deployment is. As you can see, the right side, your YAML specification, how to define deployment. Of course, you need to use deployment as kind, and then you can specify your metadata or some specification like a node selector and a template, which container you're going to use from your external container registry. In this use cases, I'm going to use my own to-do Quarkus application from Docker Hub. You can actually use Quay.io or any container registry you want to refer to pull the container image and running on your Kubernetes cluster. The one interesting part of your deployment, you can specify the replica, which means how many container will be running as a desired status. So once again, the deployment is a declarative updates for pods and a replica set, and then you can specify your desired states. So what is the replica set? The replica set, as you can, for a quick example, on your right side, the YAML specification, to specify which namespace you're going to deploy this replica set and how many replicas you want to specify to run the application all the time. So here's a quick example. You want to deploy like an app server or a microservice based on Java framework, which always needed to be running on three application pod, like a high scalability standpoint. You wanted to scale out that application pod depends on the demand, like a network traffic from your end user. So in that case, your app Kubernetes keep monitoring based on replica set, and then that application should be running all the time. The variable of a replica in this case too. New container pod is killed with some unexpected error or some kind of unconditional exception based on your hash check, like liveness readiness. And then the Kubernetes automatically restore your number of pod based on replica's number. In this case, too, if you specify replica 5, and then your all running pod always 5 should be running on top of your Kubernetes cluster. So this is how to create the leading path for desired number, the stable server running path based on replica set. So here the use case is when actually use deployment and as well as the replica set. You can create the deployment for rollout replica set as you already saw in the YAML specification. You already said it. We already specified the replicas keyword, and the number variable is 2, 3, and the default is 1. And then maybe if you specify that replicas is 0, which is there's no running pod by default. And then you can declare the state of the pod, and you can roll back all your deployment revision. So sometimes you already deploy new version based on the application code changing, but sometimes you need to roll back right away because, oh, there's some kind of bug you already find out. In that case, you just roll back just the previous version or the N-2 or N-3 version or whatever you need. There are more how to scale up your deployment to facilitate more the workloads, and then how to pause the rollout deployment. There are more use cases you can use with the deployment specification on Kubernetes. Okay, that's it. Let's get right into the run by example demo. Here, I'm going to use Quarkus To-Do application. This application provides the CRUD capability, create, delete, update, and read the application. So first of all, I'm going to run the Quarkus demo to just quick sanity test how this application looks like. So once you run Quarkus demo using Quarkus CLI or maybe Manual, you can find you can just go to endpoint, like a press W on your terminal window. As you can see, default data already created, like create default YAML and create the replica YAML, etc. When you press D from terminal window, it automatically bring you into Quark's Dev UI. And there are one great thing is Quark's application. You can have a GraphQL UI when you add a GraphQL extension on the Quarkus framework, it's automatically retrieve your old data using GraphQL UI. As you can see, you have a whole data like a create deploy YAML, replica set, and a to-do Quarkus application, something like that. You can retrieve any data without any SQL change on your code. As an example, you can edit more field, and you can find the field, the result. When you go back to application presentation layer, you're gonna check, okay, I just create the pro YAML, let's say, and then go back to the GraphQL, you can find the complete value just changing from false to true. This is one of the great thing of GraphQL use cases to avoid underpatch, overpatch compared to RESTful API. All right, let's go back to application. And here is a deployment YAML file. So just example, so deployment and using API version, API v1, and I'm going to deploy this application run by example namespace on my Minikube. And then here's my Docker container image name and tag, the to the Quarkus 1.1 version. I didn't push this image and containerized image at this yet. And then I'm going to do that just a little bit later. Here's the ReplicaSet YAML specification. The same thing, I'm going to deploy run by example. And here's one interesting part you need to understand. I specify ReplicaSet 3, which means I wanted to deploy this Quarkus application 3 pod for high availability by default, and I'm going to use the same container image like Daniel on 3.0 to do Quarkus 1.1 version. So now I'm going to try to containerize this application. You can use Docker CLI based on your own specified container Docker file. But here's just a quick another interesting part. I just specified the ReplicaSet 3 and then to the deployment 1. Maybe you actually link two different replicas value between deployment and replica sub. But I'm just showcase if you could distinguish the variable between replicas in deployment and replica sub, what happened when you deploy this application actually. I'm going to show that just a little bit later. Okay, so in order to containerize this application, I just already edited one extension on my Quarkus framework. Here we go. It's a Quarkus container image Docker extension allows developer to packaging container image. Here's my Docker dashboard. There's no to-do application image. And now I'm going to start Quarkus dev mode, and then I just build using Quarkus CLI. Quarkus build, I'm going to skip unit test with a no test parameter. It takes a few seconds to packaging your job file as well as containerize image on my local machine. So as you can see, the logs here, some kind of Docker file layers. So I just package it, and then now you can see to do Quarkus 1.1. I needed to push this image into my external container registry, aka Docker Hub. And then once I'm done, I just copy my deploy YAML and then paste it in my Minikube cluster. All right, I just copy deployment. And then let's check it out. My Minikube is running up. The Minikube status. And then you can see, oh, my Minikube is running, which is good. And then here's a Minikube dashboard, which allow me to create and add the YAML and JSON content. I just paste it and I just upload it, and you can see deployment manifesto automatically create, and a pod is running, and the replica set automatically create based on deployment specification. And then as you can see, I specify replica 1, which there's only one pod is running, which is good. So if I change the replica set directly here, there are replica 1, I'm going to change replica 3, just like the replica set YAML specification, but it's not scaled up to 3 because the deployment configuration already set the replica 1. That's why Kubernetes automatically restore back to desired status. So I'm going to change it to replica 3 in the deployment config rather than replica set. And then now you can see the 3 pods are running. So this is how it works deployment between ReplicaSet. So when you go to pod, you can see the Focus application is running. And then there is a no service, which means I cannot access my pod from external end user. So let's try to expose the deployment like a kubectl, and then using Node Portal, which allows me to access by my local environment like a web browser. And now we have exposed the service to the Quarkus. The Minikube actually mapping your service, your Minikube IP based on Node Portal capability. And now I can access my to-do application running on Kubernetes on my Minikube from my local web browser. I just need to complete all four work item as to-do list because during my demo, I just completed. So this is how it works. Deployment as well as replica set, how to scale, how many application pods should be running all the time, and how to specify which container image you want to report and pull and running on top of your Kubernetes cluster. And if you change your replica set or deployment, it how to impact your running Kubernetes cluster. And then if you already deployment config, actually you don't need to specify replica set separately because the deployment config already included replica's capability. But some cases you just only pod YAML file. In that case, you can create separately replica set YAML file to make a replica capability on your application project. Thanks for watching. See you next run by example.